Question number 27. X times kx minus 56 is equal to minus 16 or negative 16. In the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? First thing we have to observe very carefully is that this is about quadratics, because when we expand this, x times kx minus 56 is equal to minus 16. When we multiply this x with the kx, we will have k times x square minus 56x is equal to minus 16. An equation of the form ax square plus bx plus c is equal to 0, where a, b and c are constants, has no real solutions if and only if its discriminant. The discriminant part in the quadratic formula b square minus 4ac. This part, if it is negative, or in other words, if it is less than 0, then it will have no real solutions. So what we can do is, we can apply the distributive property to the left hand side of the equation and get this equation. After that, we can add 16 to both sides so that we can write it in the standard form of the quadratic. Kx square minus 56x plus 16 is equal to 0. After that, we will just compare what is the a, b, c over here. A, if you observe, a is equal to k. B, if you observe, is equal to minus 56. C is the 16. So now we will put it in the discriminant and b square minus 4ac. So minus 56 squared minus 4 times k times 16. It should be negative, or in other words, less than 0. Then we will expand this. Minus 56 squared is 3136. You can use the calculator for this. And minus 4 times 16 is minus 64. K is less than 0. We can just add 64k to both sides. So we'll have 3136 is less than 64k. Now to solve for k, just divide both sides by 64. So when you divide 3136 by 64, you will get 49 is less than k. Or in other words, k should be greater than 49. Also, it is mentioned that k is an integer. That means a whole number, positive or negative whole number. So the least possible number which can be greater than 49 as an integer will be 50. So that means, based on all the conditions, that k is an integer constant and we need the least possible value of k, we'll have to go with 50.